Mathematicians, I'm here to get you ready for your pre-AP test on Friday. Your test this week is on similarity and surface area. It's going to be covering the stuff that we learned last week and this week. Your first test question is going to be about similar shapes. I drew here in my paper two similar shapes. I have these two kind of long skinny triangles and I labeled the sides. This one's A, B, C. This one's D, E, F. If I want to compare and show that these two triangles are similar, what I'm going to have to do is show which sides are the corresponding sides. You remember that the corresponding sides are the sides that are the same, just blown up or shrunk down. So I could say here, I'm going to compare this A and C side over here. So my corresponding side to A is D, my corresponding side to C is E, and I could write that A over C equals D over E because they're just like equivalent fractions. So your question is not going to be asking you to write this down, but it's going to show you some shapes and it's going to show you a bunch of proportionalities, and you have to decide which one is actually comparing the similarity of those shapes. Our next question is looking about similar figures, and it's asking us which thing is not true. So in order for us to know which things are not true, we need to know which things are true. So similar figures have several things that we can look at. A similar figure has congruent corresponding angles. So when we blow up our figure and we change it, either increasing it or decreasing it, our angles do not change. It will be exactly the same angle. That's how come we were able to compare these over here. If this was a 30-degree angle, this would also be a 30-degree angle. They also have proportional corresponding sides. So that means while the sides are different lengths, they are in proportion. I'm not going to take this triangle and blow up one side really big and the next side shrink it down, because then it wouldn't look the same anymore. The reason I can make this proportionality is because they have proportional corresponding sides. They're also going to be the same exact shape. The thing they're not going to be is the same exact size. So if they're not the same exact size, they're not congruent. So the sides aren't congruent, the shapes are not congruent, but the angles are. So that's what you're going to need to know for your second question. The next few questions on your test are all having to do with proportionality. So it's going to be several different word questions. Two of them are multiple choice. One of them is not. One of them you just have to have the answer. And remember that the proportionalities, you have to set up your corresponding sides. And what we did is we said our known is going to be on one side. So we set up our known proportionality on one side. And then our other side is going to be our unknown. That's the one that we are looking for. And usually what it's going to be is something like this. Maybe this side has a known of a 2 and 4, and on the unknown we only have an 8, so we had to find the known side. If it's an easy one like this, then I could just make it like an equivalent fraction and I could get the answer simply. If it is not, then I am going to have to cross multiply and solve for x. You have two that are going to be like that. Your third one is kind of like it, but this one is looking at a scale drawing. So remember, our scale drawings are going to show maybe how many centimeters equal a meter, or how many feet equal a yard, or how many inches equal a yard. And so you're going to have to set up the proportionality and solve for it that way. All of these are relatively easy questions if you'll just set them up and do them the way you were taught. I do want to tell you, make sure you write this down. Known and unknown with an example of what it might look like. You can use these numbers or you can use your own numbers, but this right here does need to be on your notes for the test. All right, your next few questions are going to have to do with nets. And so, first of all, we're going to look at this one here. Right here, I do have the net of a triangular prism. It's like the triangular prism that's in your interactive notebook. Over here, I have another triangular prism, but this one looks a little weird, doesn't it? It's just a little bit different kind of a net. You can have a lot of different kinds of net that represent the same thing. You are going to have to know what the lateral surface area is for a net. So if I had one that looked kind of like this, and that one looks a little weird. Maybe it might look a little bit more like this. We can put the triangles kind of to one side. The triangles are going to be the base. So the base is the part you don't need to figure out. So that's kind of good. It means you don't have to do the triangle equation. You're going to have to do area for rectangles. But you are going to have to do the other equation in order to figure out your lateral area. So you would be using a three-dimensional figure, you're going to be figuring out the lateral surface area. That means you only have to worry about the rectangles. You don't have to worry about the other kinds of shapes that are in there. You also are going to be looking to see what kind of a net might make a different figure. So you should be looking through your interactive notebook and kind of thinking, what kind of nets do you have? So when we're looking at rectangular prisms, they're going to look kind of like a cross, kind of like this, because they're kind of long. If you're looking at a cube, they're all going to be perfect squares, and that's going to make a cube. If you are looking at a triangular one, we already looked at the triangular prism here. Remember, we said a triangular pyramid looks like this, kind of like Zelda. And then we have these square pyramids, and they look like the ninja throwing star. So you're just going to have to look and find which net goes with the problem. All right, our next question is a little bit difficult. It's a little different than some of the ones we've done. It is taking composite shapes. A lot of the composite shapes we used was something more like this, where you take a square and you add a triangle onto it to make a house, and you're finding the surface area of that. In this particular case, we're taking a square, and we're going to be taking another square out of it. So maybe it's a square like this, or maybe it's a square like this. And what we're doing is we're only finding part of it. We're not finding all of it. So if I was doing this one and I only wanted this, and I didn't have the dimensions for this, but I had the dimensions for this and this and this, I might be able to subtract it. Here, if I had the dimensions for the outside and for this part, but not for the middle, I could figure out the big part and I could subtract it. Or I could subtract these edges from the big part and find the middle so that I can find the answer. It's kind of a common sense kind of thing. So we have one that you're going to be taking a big square, and you have a little square in the middle, and you're going to have to be looking at that and figuring out, even though I don't have the dimensions on the little square, I can figure them out for the dimensions of the big square, and from telling me how big, how wide this little area is right here. Your next question is similar. It's another one that has a bigger shape, and then it's got some shapes that are taken out of it. And you need to figure out how much of the garden is going to be working for something here. So I've got some stepping stones in this garden. I had the dimensions of the stepping stones. I had the dimension of the whole garden. But I got to figure out how much of the garden I can actually grow something in that I'm not standing on. So you're going to have to find the little pieces and then subtract that area from the area of the big piece. Okay, your next question is going to be something like this. When we looked at this house, I could tell you, all right, I'm going to give you a ruler. In fact, there's going to be these rulers at my desk. They're these handy-dandy little centimeter rulers. And you could take the ruler to measure the dimensions of the scale model of this house. I could see that that's about 1 centimeter that way. And if I wanted you to go to the nearest ½ centimeter, I went to my next one. Let's see. And that is really close to 1½ centimeters. So my dimensions here would be 1 times 1.5 in order to find out the area of this. And then I'd have to figure out the area of my triangle, which you remember that is BH over 2. The one that you're going to be working on is actually going to have a circle. So remember when we have our circle, we said that the way to find area for circle is pi r squared. If we're dealing with a semicircle, it's pi r squared over 2. So then you're going to take that along with the area of your rectangle or your square, and you're going to add those together. You're going to be using your ruler. It's going to ask you which one is the closest, because some of you might measure just a little bit off. So you're going to look at the number that's the closest. It might be rounded, but it's going to be really close to the answer that you have. Okay, our very last question is another net question, and it's going to be showing a pyramid. Remember, all you're doing is you're going to be figuring out the area of your base, then you're going to be figuring out the area of each of your triangles, and then you're adding them all together. Your last one is not a multiple choice question, so you're going to have to figure out the area and have the correct answer. Remember that it has to be squared because it's area. So the things that you need to write on your test. We said you needed to write your known and your unknown. You should already have that written down. You should have written down that area is always going to equal a number that is squared, so that you remember to square your answers. You're going to remember to write down to use your formulas. Write them down first, and also to use your proportionalities. So you don't have a whole lot of notes for this test. It has 12 questions. When you're done, you'll be entering your questions online. Have a good day.